So in this video, all we're going to do is look at a possible equation that you could be asked to solve that involves complex numbers. And in this case, you'd be trying to find z in the form of x plus yi. And the first thing we want to do is get rid of the denominators. And so we would multiply both sides by z times z conjugate. And so this gives us 50z minus 10z conjugate equals 2 plus 9i. And now, if you remember back to the properties of the modulus of complex numbers video, you know that z times z conjugate is equal to the modulus of z squared. So we know that this will be multiplied by the modulus of z squared. I'm sorry, I forgot a very important piece of the problem. It also tells us that the modulus of z is equal to 2 root 10. So that means that that's going to be 2 root 10 squared. So 2 plus 9i times 2 root 10 squared, which is going to be 10 times 4, which is 40. So that's going to be 2 plus 9i times 40. So the next thing we're going to do is break this up into x plus yi. So we have 50 times x plus yi minus 10 times x minus yi is going to be equal to 80 plus 360i. So then 50x minus 10x is going to be 40x, and it's going to be 50yi plus 10yi, because the negatives will cancel each other out, so that's going to be plus 60y. I is equal to 80 plus 360i. And then what we're going to do is we're going to set the real and imaginary parts equal to each other. So 40x equals 80, and 60y equals 360. So we're taking imaginary parts here, the real parts over here. X equals 2. Y equals 6, so we know that z is equal to 2 plus 6i. And so that's just an example of how we can use the properties of the modulus, but also just complex numbers in general in an equation.